All right, hello, Algebra 1. Welcome back. Today we are doing something a little bit different. We're sort of jumping ship a little bit, and we're talking about square roots or radicals, and we're talking about simplifying radicals. Um, so you should have seen with your warm-up that some square roots, when taking the square root of some numbers, you don't always get nice numbers. Sometimes you get these ugly decimals that go on and on and on. These are irrational numbers. Um, so we're going to talk about how we can simplify square roots in a way that we can write it without having to write it as a decimal. So it's still exact, but it's not an ugly number that I have to write all these decimals out. But it's still the exact form, but it's an easier way of writing it. But it doesn't look like this square root of some number that I don't know. So when we are simplifying square roots, we are going to do a method called the factor tree. So the cool thing about so when we think about a square root, you're thinking about what two numbers multiply together to create that number. So like what two numbers multiply to create 4, 2 and 2. What two numbers that are the same multiply to create 25? Well, that's 5 and 5. So we're breaking it down into those factors that are those numbers that multiply together to create that value. So when we're going to start simplifying square roots, we are always going to start by breaking these numbers down into their factors, their prime factors. So I'm going to break these numbers down as far as they can go. So 20 is a number. I can think of two numbers that multiply to create 20. Well, 4 and 5 create 20. So I'm going to continue to I'm going to create this little tree. I'm going to continue to break these numbers down as far as they go. Can 4 break down any farther? Can I think of any two numbers that multiply to create 4? Yeah, 2 and 2 create 4. Can I think of any numbers that multiply to create 5? Well, 1 and 5 create 5, but that's not really going to break down my numbers at all. It's just going to give me a 1 extra and a 5 extra. So we're going to break these down into essentially what are known as their prime factors. So prime factors, once again, a prime number is a number that can only be created by multiplying itself in 1. So 2 is a prime number, 5 is a prime number. So I have broken this down into just its prime factors. This 4 is essentially gone because I have broken it down. So once we break down this number into just its prime factors, I can't break down 2 anymore. I can't break down 2. I can't break down 5. Once we break these numbers down into their prime factors, we are going to look for some pairs. So I'm going to look, do I see any pairs of numbers? Well, I have a pair of 2s. So when you have a pair, we're going to circle that pair, and you are going to cross one out. We're going to circle that pair and cross one out. We are then going to take that number, and we are going to write it below. So I circled a pair, crossed one out, and I wrote one below. I'm going to do that for all my pairs I see, which in this case is only 2. I'm then going to look at my other numbers that do not have a pair. So 5 does not have a pair. So I'm going to write a radical sign. And for every number that does not have a pair, it needs to go back inside my radical sign. So 5 did not have a pair, so it has to go inside my radical. 2 did have a pair, so I wrote it outside my radical. So a trick to remember is if the number has a pair, it goes outside the radical. If it doesn't have a pair, it goes inside the radical. A way to remind yourself of this is if you have a friend, you can go outside and play, but if you don't have any friends, you have to stay inside. So 5 didn't have any friends, so he had to stay inside. 2 had a friend, so he was able to go outside. Now this right here, 2 radical 5, is this simplified version of 20. It's a simplified version of radical 20. If you were to put radical 20 in the calculator and then put 2 radical 5 in the calculator, you would get the exact same answers. Now, it doesn't necessarily look as simplified, but we've broken it down to nicer, smaller numbers that are easier to work with, making it simpler for us. Let's look at another example, 32. So once again, I'm breaking 32 down into prime factors. I need to think what numbers multiply to create 32. Well, the first one that came off to my head was 4 and 8. 4 and 8 are numbers that multiply to create 32. Well, 32, I can also break 4 down into 2 and 2. So 2 and 2 is a way of breaking down 4. 2 and 2 are both prime factors, so I can't break those down any farther. But 8, I can break 8 down farther. 8, I can break down into 2, and 4 are 2 numbers that multiply to create 8. Well, 4 also breaks down into 2 and 2 as well. So I got a bunch of 2s. And I know this 4 and this 8 and this 4 have all disappeared because as soon as I break that number down, it's gone. It disappears. So now that I broke all my numbers down, I have a bunch of 2s here. I need to look for pairs. So what pairs do I have? Well, I have a pair of 2s. Here's a pair of 2s. Now remember, every time we find a pair, we cross one out and then write the other number on the outside. So I have a 2 on the outside and another 2. And then every number that didn't have a pair has to go inside my radical. Well, what about I have 2 2s on the outside? What am I going to do with those? If I think about all these numbers multiply together to create 32. All these numbers are multiplying to create 32. So my numbers on the outside are going to have to multiply together. So what is 2 times 2? Well, 2 times 2 is 4. So 4 radical 2 is the simplified version of radical 32. 4 radical 2. 2 times 2 is 4, and I still have that radical 2. Let's do 128. So we need to think what numbers multiply to create 128. Well, 128 can be broken down. If you have trouble coming up with numbers off the top of your head, if it's an even number, you know it's always going to be divisible by 2. So I can divide this one by 2. And if I divide it by 2, 64 is my other number. Well, 2 won't break down, but 64 can break down. 64 can break down into 8 and 8. And I know. So here's a trick. Here's a trick. I'll teach you this trick. I can keep breaking 8 and 8 can keep breaking down farther and farther. 8 can break down in 4 and 2, and then 4 can break down in 2 and 2, and the other 8 can break down the same way. But if I'm always looking for pairs in the end of my problem, I have a pair right here. Even though these numbers can break down farther, if I have a pair of the same number, I can always circle that pair. So I don't necessarily have to break down 8 farther. I can circle a pair, cross 8 out, and then my other 8 gets to go outside. While 2 here did not have a partner, so it is stuck inside. So I have 8 radical 2. And this is a shortcut rather than having to break down 2 farther and farther and farther. So 8 radical 2 would be one solution. Now, sometimes we're going to be left with multiple numbers that don't have pairs. So for example, if I had a 3 as well that didn't have a pair, 3 would also be written inside my radical. Now, like my numbers outside my radical, I can multiply them together. So if I have a 2 and a 3 under the radical, they can be multiplied together, and that'll give me 6. Can't remember if I have any options that do that. I'm gonna keep moving on because I don't have too much time. So students simplify radical 32 with the following work. How can we simplify this further? Well, looking at this problem, we actually did this one already. We saw radical 4 turned into 2 and 2, which they circled and crossed one out and turned into 2. But radical 8, we know radical 8 could break down farther. We know that broke down into 2 and 4, and 4 broke down into 2 and 2, which we could then get another 2. So we could actually throw our other 2 on the outside, and this should be 2 on the inside. So we actually just solved that question. So they didn't break down radical 8 enough. So always remember, try to break your numbers down as much as possible, unless you get 2 pairs and you can stop early. So what happens if it has a number on the outside of the radical, like 3 radical 20? Can I still simplify this? Yeah, radical 20 can still simplify. This radical 3 does nothing to my problem, or that 3 on the outside of my number does nothing. All I need to do is essentially forget about it until the very end. So this 3 radical 20, I'm just forgetting about the 3 all the way to the very end. And we already actually broke down radical 20. We saw it was 4 and 5, which we know 4 breaks down into 2 and 2. Circle 1, cross it out. I have a 2 on the outside, a 5 in the inside of my radical. Now this 3, it's going to come down all the way to the very end. I'm going to put it on the outside because 3 was already a number on the outside, so I'm just going to put it on the outside. We know all our numbers on the outside are being multiplied by each other. So 3 times 2 is going to be 6. So 3 radical 20 is going to simplify into 6 radical 5. Once again, you can plug both of these into the calculator, and they will get you the same exact answer. They're equivalent. It's just an easier way of writing it. Let's do one more. 2 radical 48. Well, 48 can be split into 6 and 8. I know 6 can be broken down into 3 and 2, while 8 can be broken down into 2 and 4, which 4 can be broken down into 2 and 2. So looking at my pairs here, I have a pair of 2s. I know 4, 6, and 8 all disappeared. They were broken down. So I cross one out of each of my 2s, and I have a 2 times 2 on the outside of my radical. And then the inside of my radical, poor little 3 didn't have a partner, so he's stuck inside. But I'm not yet done because I had this 2 on the outside that needs to be brought down. So I'm going to put one more 2 outside. So one trick, one thing that I tend to see students is they'll just forget to bring that number that was outside. They'll forget to bring it down in the problem. They'll solve the whole thing, and they'll forget this. And so 2 times 2 times 2 is 8 radical 3. So 2 radical 48 simplifies into 8 radical 3. Once again, plug them into the calculator, and they're exactly the same. I'm going to skip that last one. You guys can take it. You can pause the video and try it. So adding and subtracting radicals. So when we have two numbers, like 11 radical 6 plus 2 radical 6, we can add and subtract radicals that are like terms. In order for a radical to be a like term, they have to have the same number under the square root. So for example, 6 and radical 6 and radical 6, these are equivalent radicals. They would be considered like terms because they have equivalent radicals. Now, 11 radical 6 and 2 radical 6, what I'm going to do is, just like if it was a variable, I'm going to add or subtract my coefficients. So if I have 11 radical 6 and 2 radical 6, I can add 11 and 2 together to give me 13 radical 6. And that would be my simplified answer. We can just take those coefficients of those radicals and add them together. Same with subtracting. So once again, we have to look for like terms. So for example, 4 radical 3 is only going to be a like term with 5 radical 3. So if I have 4 radical 3 and a positive 5 radical 3, I can add 4 plus 5 to give me 9 radical 3. Looking at my other like terms, I have negative 2 radical 11 and 6 radical 11. Negative 2 plus 6 gives me positive 4 radical 11. Now, radical 3 and radical 11 are not like terms. They do not add together. So we'll just leave this as 9 radical 3 and 4 radical 11. And once again, you can pause the video and try that last one. I'm scooting along here, Multiplying radicals. We can do operations where we multiply radicals as well. When we are multiplying radicals, if we think about every number inside a radical, when we had like radical 48, all of those numbers were multiples. They were factors. They multiplied together to create 48 or to create 25 or to create 24, whatever that number was. So when we are multiplying radicals, we just need to think of it as two things. We have the numbers on the outside of the radical. We have the numbers on the inside of the radical. We know all those numbers on the outside of the radical can multiply together. All those numbers on the inside of the radical can multiply together. So when I'm going to rewrite this, I'm going to rewrite this as 3 times 8. I'm going to take my outside numbers, multiply them together. And then I'm going to multiply my inside numbers, 5 times 6. So 3 times 8, 5 times 6. Assuming these are simplified already, we probably don't need to simplify any farther, but sometimes we might. I don't think I have an example of that. So 3 times 8 is going to equal 24. 5 times 6 is going to equal radical 30. Now, if you need to, I would check that radical 30 just to make sure it doesn't break down any farther. So, because sometimes this number might break down a little bit farther. In this case, it shouldn't, because if we break this down into 5 and 6, that's going to break down to 3 and 2. All of these numbers are prime factorizations. They don't have any pairs. So 30 is actually as simplified as it's going to get. 30 is not going to be simplified any farther. So 24 radical 30 is actually the correct answer. But sometimes when you multiply two numbers, you might get two pairs that multiply together. And so it might be able to be broken down farther. For example, if you had, I'll just create an example. 2 radical 3 times, 3 radical 6. This is going to be my example. We know 2 and 3 multiply to get 6 on the outside. On the inside, I get 3 times 6, which is 18. Well, 18 breaks down into 2 and 9. 9 can break down into 3 and 3. That's a pair. So I have a pair, so I could cross that out, and I'm going to put that 3 on the outside. So I would have 3 times 6 on the outside of my problem, and 2 is left on the inside. So it's actually going to become 18 radical 2 compared to 6 radical 18. So sometimes we do have to break it down farther. Sometimes we do have to watch out for that. Now, just like with equate, or just like with a variable, if the number does not have a radical or a coefficient on the outside, you can assume that coefficient's 1. So 5 radical 5 times 11 radical 13, we can multiply that together. 1 times 11 is 11. 5 times 13 is, let's see, that is 65. So it's 11 radical 65. 65 will not break down farther because it's only a factor of 5 and 16, or 5 and 13, I apologize. And so that would be our final solution. And lastly, before we leave today, we have dividing radicals. So 30 divided by radical 2, 21 divided by radical 3, and radical 14 divided by radical 2. So 30, when we are dividing radicals, we have something called rationalizing the denominator. as mathematicians, we hate having a radical in the denominator of a fraction. We don't like it. It's like if you were to write a sentence and you were to not use any punctuation or to not capitalize, it just looks bad. And so as mathematicians, we don't like having these radicals in the denominator. It looks bad. And so what mathematicians do is we do something called rationalizing the denominator. We rationalize the denominator. So what we do for rationalizing the denominator is we will take the radical and we are going to multiply by radical 2 over radical 2. So we are going to look at what is that radical in the denominator, and we are going to multiply that we are going to multiply our fraction by another fraction that is that radical over that radical. Now the reason I can do this is radical 2 divided by radical 2 is just 1. Anything divided by itself is 1. So I am actually only multiplying by 1, which anything multiplied by 1 stays the same. So I am not changing my problem in any way. I am not changing this answer. It's still going to be equivalent to 30 over radical 2. Because I'm just multiplying by a very fancy form of 1. But the reason we're doing this is 30 times radical 2 we know is just going to be 30 radical 2. My number on the outside and my number on the inside. While radical 2 times radical 2 is going to turn into radical 4. Well, what is radical 4? Radical 4 we know is just 2. The square root of 4 is 2. We know that. We could break that down as 2 and 2. That's a pair. So the square root of 4 is just 2. So this is 30 radical 2 divided by 2. My radical disappears because there's no number inside the radical. So if we were to break down radical 4, which we already know the square root of 4 is 2 and 2, but we would get a pair of 2s, we'd circle it, cross it out, and I'd get a 2 outside. There's no number that didn't have a partner, so there's nothing that's going to go in the radical, so my answer is just 2 at that. So that's how I got this 2 right here. Well, 30 times radical 2 divided by 2, 30 and 2 are both numbers that are outside the radicals, so I can easily divide these just as I normally would. 30 divided by radical 2 is 15. Or sorry, 30 divided by 2 is 15. So this is 15 radical 2 would be the simplified version of this fraction. I could keep going with this one. 21 divided by radical 3. Once again, I'm going to multiply by that radical over that radical. So radical 3 over radical 3. I'm always just going to take whatever the radical is in my denominator. My numerator is going to be 21 times radical 3, which is just 21 radical 3. My denominator is radical 3 times radical 3, which turns into radical 9. I know square root of 9 is already 3, so this is going to be 21 radical 3 over 3. Well, what's 21 divided by 3? 21 divided by 3 is 9. Sorry, not 9, 7. What am I doing? 21 divided by 3 is 7. So 7 radical 3 is going to be my solution. So you actually can probably catch a quick shortcut. What shortcut could we do to get from here to here without having to do any of those actual steps? Well, if we look at both of these, if I think 30 divided by 2 is 15, 21 divided by 3 is 7. So one shortcut you can do is you can take that numerator, that number in the top, divide it by whatever number's in the radical. So 30 divided by 15, write that down. Or 30 divided by 2 is 15, write that down. And then take that number that's in the denominator, take that radical that's in the denominator, and just add it onto the end of that problem. So for example, if we had 28 over radical 7, let's say. Well, I could easily shortcut this by doing 28 divided by 7. 28 divided by 7 is 4. And then take that radical and add it to the end. And that would give me equivalent answer. 28 divided by radical 7 is the same as 4 radical 7. 21 divided by radical 3, 21 divided by 3 was 7. Add the radical 3 on the end. And that's all we have to do. So that's a quick shortcut you can try. Now, this last one is a little different, though, because I have a radical in my numerator and my denominator. Well, if I think about it, I know all the radicals, all the numbers and radicals are being multiplied together. They're all factors, so they multiply together. Well, multiplication is just the inverse of addition. So if they can multiply together, they can also divide together. So when I have 14 over radical 2, I could multiply this by radical 2 over radical 2. Or I can just think, what is 14 divided by 2? Because this is equivalent as 14 over 2. When you have two numbers that are in the radical that are either being multiplied together or divided, we can just simply do the operation with those numbers and just put the radical around it. So 14 divided by 2 is just going to give me 7. So this is just going to be radical 7 as the answer. So radical 14 divided by radical 2 is equivalent to radical 7. That's where we're going to end it for today. I know I was jumping around doing a little fast this video. If you want to go back and pause and go back to some of the questions and solve it, go for it. I would recommend it. But you'll have a little bit of practice over this today as well. Let me know if you're confused on anything. Let me know if you have trouble with these radicals. We'll talk about how this relates back into quadratics in a bit.